In this section, we would like to introduce polynomials and simplifying them. First of all, a polynomial is a series of terms that are being added or subtracted. Now, these terms are made up of constants and variables and whole numbers and such. So an example is 3x plus 7y minus 10. Now, if you notice, there's different parts to this. So what we want to think about is anytime we're considering something that's called a term, the 3x is a term, the 7y is a term, and the 10 is also a term. But then we like to talk about those terms a little bit more specifically. So if you notice that the first term is 3x, it has a number attached to it. Well, that number that's attached to that x, that 3, is actually known as the coefficient of x. Then we have this next term of 7y. Well, the number in front of it is a positive 7. So it turns out that the coefficient of the y is 7. We also have variables that are going to counter inside of our polynomials. And the variable is the letters. So notice that our first term is the 3x. Well, it has a variable part of x. The next term is 7y. It has a letter in there as well, so that is our variable of y. Now, the constant is usually just a number itself that doesn't have any variable attached to it. So if you see a number that's just being added or subtracted, then that will be your constant. In this case, we have a minus 10. Now notice this time around, since there's a negative in front of it, when we talk about our constant, we will include that sign of our negative. And notice we technically did that on the others, the 3 and the 7. There was no sign in front of them, but those are always understood to be positive for us. So what we want to think about is if we're given a polynomial like 3x plus 7y minus 10, is there any way that we can go through and simplify that? And what we want to look at is to simplify polynomials. Our basic steps are to go through and combine what we call like terms. So now you may ask yourself, well, what are like terms? Good question. Like terms are when we look at these terms and their variable parts are identical. So what we're looking for is that the variable part is the same. The numerical part, the coefficient, that can be any number. And when we go ready to simplify them and we combine the like terms, the numerical part is what we're going to be adding or subtracting. So just to give you an example, think about if we had the term of 3x squared, and maybe we had something like 8xy, and then we had maybe a negative 12 x squared y. And then let's make up 3 more terms. So let's think about something like 5yx. Let's maybe do a 1/2 because your coefficient doesn't have to always be a whole number. It can be a fraction as well. And let's have maybe xy squared. And our next one we can make up, let's make it a negative 23 x squared. So what we want to think about out of these terms that we have listed, are any of those terms actually like terms? So what we want to do is look at our first term of 3x squared. Ignore the coefficient of 3 and look at just that variable part that you see left over, so the x to the second power. And what we want to do is look at all the other terms and see if we have one of those that looks the same. So there's our 8xy. But no, it doesn't have x squared. Our negative 12x squared y. Yep, there's the x squared, but notice this time around there's a y also. We didn't have a y on the original, so that's not actually a like term. But if you go to the next column over, down at the very bottom, that negative 23x squared, if you ignore the negative 23, there's the x squared, and that is the same variable portion as what we had in the first term. Now when we're looking for the same variables, they have to be raised to the same exponents as well. So 3x squared and negative 23x squared are, in fact, like terms. Okay. Second term we have in here is the 8 times x times y. So we're looking for an x to the first power, y to the first power. Well, notice the one below it doesn't match because it has x squared. The one across from it doesn't match because it has y squared. But the 5yx, that one has a y to the first power, x to the first power. Not in the exact same order, but that's okay. If you recall some of your properties of numbers, it doesn't really matter what order you multiply two numbers in, you'll still get the same result. So 8xy and 5yx are also like terms. So that means that they could be added together or they could be subtracted. Now the last ones we have left, we have the x squared y to the first, and we have x to the first y squared. Same variables of the x and y, but notice that the x is squared in one of them, and in the other one it's raised to the first power. So those are not like terms. That means that we could not actually add or subtract those. So remember, to find like terms, we're looking for the exact same variable raised to the exact same power in both terms. So let's look at a couple examples. First one here, we have a 4x minus 9y minus 7x plus 7y. I always like to start at the very beginning on the left-hand side, and the first term that I see there is 4 times x. So I want to look to see, are there any other terms in that expression that also have a variable of x in them? And yeah, if we skip over, there's a negative 7x. So we want to combine those two together. So now we have 4 minus 7, which is negative 3. And they both have that variable of x, so we always hold on to that. It's kind of like thinking about if you have 4 apples and you add 3 apples to it, you still have apples in the end. The next term that we see in the line is negative 9y. So now we want to check to see, are there any other terms in that expression that also contain the variable of y? And notice there's only one term left at the very end, and that is a positive 7y. So negative 9 plus 7 will subtract and give us a negative 2y. So we were able to combine like terms and now have the result of negative 3x minus 2y. Our next example looks a little bit different. Now we have 3 times y plus 4 plus 6 times y minus 5, and then a plus 7. This time around we have parentheses inside our problem, and anytime you see parentheses in a problem, you want to think about distributive property. So we want to take our 3 and multiply it by the y. We want to take our 3 and distribute it and multiply it by the 4. So 3 times y is 3y. Our 3 times positive 4 is plus 12. Parentheses have ended, so we're done distributing. So next thing we see is this plus 6 times y minus 5. Another set of parentheses. So let's now distribute our 6. So we have 6 times y and 6 times negative 5. So positive 6 times positive y is our plus 6y. Positive 6 times negative 5, so positive times negative is negative 30. Parentheses are ending, so now we're done with distributing our 6. And the last thing in our expression is that plus 7, so let's bring that straight down. After we've gone through and cleared out our parentheses, now we want to go through and see, do we have any like terms that have appeared along the way? So again, I like to start at the left. So my first term that I see is 3y, and I want to look to see, are there any other terms in this expression that also contain that variable of y? And notice there in the middle, we have a positive 6y. So 3y plus 6y is going to give us a total now of 9y. So keep going. Notice now we have a positive 12, so it's a constant. It is just that number by itself. Down the line we have our negative 30, and we also have a plus 7. So we have 3 terms now that we have to combine together. So we've got our positive 12 minus 30 plus 7. Now, when you're adding and subtracting the numbers, you can combine them in any order that you like. So if you find one combination that might go a little easier, then you can do that. So notice if we take 12 minus our 30, we now have negative 18. Now, negative 18 plus 7 is going to give us back a result of negative 11. So it turns out that now our simplified form is 9y minus 11. Last example, and this one actually has some fractions inside of it. So what do we do when there's fractions? No, it's still the same thing. We want to check to see, are there any like terms? So this first term that we have here has that variable of x in it. And if you look at the very end, there's another term with that variable of x. So we've got to take our 5, 6x and subtract 3, 11x. But there's a rule about adding and subtracting fractions, and that means that they have to have a common denominator. So before we can actually combine our like terms, we have to find that common denominator, or a lot of times you'll hear it referenced as just your LCD. So we need our LCD of 6 and 11. That means we're looking for the smallest number that 6 will divide into, but at the same time 11 will divide into it as well. So a little trick. Start with the larger of the two numbers. Well, 11 is definitely divisible by 11, but is 11 divisible by 6? Not so. So that means we've got to think about as a multiple now. So this number is going to be larger than 11. But if you also notice, 11 and 6 have nothing in common. There's no numbers that will divide into both of them. So in that case, take your 6 and your 11 and multiply them together. And it turns out that 66 is actually the smallest number that 6 will divide into, that 11 will divide into also. So what we've got to do is go back to our original problem. We had that 5 over 6 times x. We have to rewrite that. We need this denominator now to be a 66. So notice to get 66, we actually have to take 6 times 11. But whenever you're working with fractions, whatever you do to the denominator, you have to do to the numerator as well. So we have to multiply both the 5 and the 6 by 11. So now 11 times 5 is 55, and in the denominator 11 times 6 is 66. And then keep our x. Now I'm going to go ahead and take the next fraction and bring it down. Remember, it's got the minus in front of it, so it's still a negative. But we have the 3 over 11 times x. But to be able to subtract these two fractions, they have to have that common denominator of 66. So notice the 11, we have to multiply it by 6. That also means in the numerator, that 3, we have to multiply that by 6 as well. And notice what happens. Bring down our minus sign, because that's not going to change. In the numerator, 6 times 3 is 18. 6 times 11 in the denominator is 66. And then bring down our variable of x. And don't forget, there was still this term up there in the middle, that plus 7/8 didn't have a variable attached to it. But we can't lose it, so let's go ahead and bring it down as well. So we've changed the problem. It's now 55 over 66 times x minus 18 over 66 times x plus 7 over 8. So now that these two fractions have a common denominator, remember your rule. It says that keep that common denominator and add or subtract the numerators. So we now have 55 minus 18, which will leave us with a 37. And they both have that variable of x in common, so let's keep our variable x as well. The last term that's sitting up there is at plus 7/8. Since it's the last term, there's nothing to add or subtract from it, so let's bring down our plus 7/8. And now we have our answer.